Hey peeps, it's Jedd here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today, we're going to deal with a geometric sequence question, and with that in mind, let's dive straight in. So they've said to us the sum of the first three terms of a geometric sequence is 91, and its common ratio is 3. Determine the first term of the sequence. So the information they've given us is that the sum of the first three terms is equal to 91, and they've given us that the ratio is equal to 3. Now, we know what the formula is to sum a geometric sequence up to the nth term. That is going to be the first term times r to the n minus 1 over r minus 1. Now let's sub in the variables we know and see if we can solve for the first term with that in mind. So we know that they've said to us it's sum to 3. The first term is what we're trying to figure out. The r is going to be 3. The n, we looking at the first three terms, minus 1 over 3 minus 1. What's really nice is once I plug in the S3, I will only have the a that is missing, and that's the one we're trying to solve. So let's plug in our 91 equals a 3 to the 3 minus 1 over 3 minus 1. Right, now we can start looking to solve this. So I'm going to continue up at the top just to save some space. So I'm going to simplify quickly. It's going to be 91 is equal to a. Within the brackets, I've got 9 minus 1. 27 minus 1. So 3 cubed is 27. Minus 1 would give us 26. Over, and then we've got 3 minus 1, which is going to give us 2. Moving on to the next step, we've got a. So the 26 divided by 2 is going to give us 13. Right, so 13a. And now we can divide both sides by 13. So 91 divided by 13 gives us 7. And that solves the answer for this particular question. Very special thank you to our sponsor for making this video possible. Be sure to read all about them in the description below. Also head over to our website for more of these epic tutorial videos. If you can't find the answer to your question, send us the question and we'll respond with a personalized video just for you. Until the next time, stay epic.